Good morning from the high hills of Santee. It is a little chilly out this morning, and we're going to go over some gas behavior and how it relates to the changes of states of matter. So the big things I wanted you to make sure that you understood from this section have to do with the pressure, and then Charles' Law and Boyles Law, two of our big gas laws that we're going to be talking about. And these are our two guiding questions from this section. How do changes in particle motion of a gas affect physical properties, and how are the temperature, pressure, and volume of a gas related? So let's skip ahead. And here's a volleyball. We're not going to talk about the volleyball. We're going to talk about our blue football that we play with on our field out here because we're on the field. So pressure and temperatures of a gas. The pressure of a gas is the force of its outward push in newtons over an area in square meters of the walls of the container. So you should have this already. P equals F over A, so pressure equals force divided by acceleration. By area. So pressure equals force divided by area. I'm still mesmerized by acceleration. Pressure is always measured in pascals, and we'll talk about why next week when we get back from break. Pressure is measured in pascals. So pressure of a gas is the force of its outward push on a volume. So this football has a certain pressure depending on the amount of gas that's inside of it. Pretty easy to calculate and makes sense, right? Simple stuff. So we're going to talk about two gas laws, but before we do that, make sure that you realize the pressure inside of this ball drops until it's equal to the pressure outside if there's a hole, and over time it will do the same. So you can see this ball needs to be inflated, and there's a little nozzle here where you can inflate the ball, put the little thing in, and you pump air into it, and it increases the volume of the gas inside of this ball. Temperature can also affect the pressure of a gas. So it's cold out here. It's not cold, it's chilly. It's 50 degrees, 48 degrees, whatever it is, as I'm watching cars arrive here in the morning. And there's condensation and it's a little chilly. So the gas particles inside of this ball are actually sort of huddled close together, just like you would with your friends. You know, when it's chilly, you kind of put your hands in your pocket and you just sort of huddle up, and you might sort of squeeze in with your friend. Same thing with the little gas particles in this ball. They're just like 8th graders or 10th graders or 6th graders or anybody really. So temperature also affects the pressure of a gas. And that leads us to our two big gas laws that I wanted to talk to you about today. Number one is Charles' Law. And we're going to talk about Jacques Charles when we get back. He's a French guy, very important principle in physics and in physical science and chemistry. But Charles' Law says when the temperature of a gas at a constant pressure is decreased, the volume decreases. So it's cooler out here. Later on today, it's going to be about 70, 75 degrees maybe. So the volume inside of this ball will actually expand. Even though it's the same amount of gas, we're not putting any more air into it. So on a hot day, a ball will expand, a substance will expand. There's a big truck. That's Charles' Law. And then that's a directly proportional relationship. So as the temperature decreases, the volume will decrease. So you can squeeze on a ball when it's a little chilly more than you can when it's warm. So that's why also, if you ever watched football, there's a whole thing about depressurizing balls and whether or not Tom Brady cheated when he was with the Patriots by having more deflated balls because it increases grip, as you can imagine. It was a big thing a couple of years ago about that. And that's all related to Charles' Law. But when the pressure is decreased, the volume increases at a certain temperature. So pressure and volume are related, and this is where we get what's called Boyles Law. So Boyles Law, oops, we'll highlight this here. Robert Boyle, who was a direct frenemy, if you will, of Isaac Newton, said that when the pressure is decreased, the volume increases. So when the pressure decreases, the volume increases. So when temperature decreases, volume decreases, but when the pressure decreases, the volume increases. So it's opposite. Hey, we've got students over there. Very exciting. And that's Boyle's Law. So that's Robert Boyle, who was head of the Royal Society, and their motto was nullius in verba, like our motto here at Thomas Humphrey is acta non verba. Nullius in verba means don't take anyone's word for it, do experiments. So two main gas laws, Charles' Law and Boyle's Law. And then we have this fascinating way to graph Boyle's Law, which we're going to do in class. I'm very excited about that. And we're going to close it out with inversely proportional relationships. So again, Charles' Law is when temperature goes down, volume goes down, like a football. Boyle's Law, when the pressure goes down, the volume is inversely proportional. So we're going to talk about that. And that's it. And we're going to talk about pistons in class and how they relate to pressure and volume and temperature and pressure, because they're all related in different proportions. So temperature and pressure, temperature and volume, Charles' Law, Boyle's Law, two main gas laws, and I can't wait to experiment and demonstrate with you in class.